In 2003, the International Engine of the Year award went to a Wankel Rotary, not a turbocharged V8, not a hybrid system, a design the engineering world had written off, and Mazda had just proven them wrong. 8 years later, Mazda quietly ended production in Hiroshima. No press conference, no farewell, just the last cars off the line, and then silence. So, how does an engine win the world's highest recognition and disappear within a decade? To answer that, you have to go back to where the obsession began. Most car manufacturers are built on pragmatism. They follow proven technology, manage risk carefully, and move toward whatever the market demands. Mazda was never quite that company. In 1961, Mazda signed a licensing agreement with the German firm NSU to develop the Wankel rotary engine for production use. Nearly every other manufacturer that had looked at the Wankel design had walked away. The engine was brilliant in theory and deeply complicated in practice. The sealing problems alone had defeated engineering teams across Europe. Mazda looked at the same problems and decided to solve them anyway. 6 years later, in 1967, the Cosmo Sport 110S rolled out of Hiroshima as the world's first production rotary-powered car. It wasn't just a vehicle, it was a statement that Mazda had done what no one else could. The rotary engine's appeal was almost philosophical. No pistons, no valves, no valve train. Just a spinning triangular rotor orbiting inside a precisely shaped housing, producing a power stroke with every face of the triangle on every revolution. The mechanical elegance of it was unlike anything a piston engine could offer. Fewer moving parts, a compact package, a power delivery that felt smooth in a way that four-cylinder engines of the era simply couldn't match. Through the 1970s and into the 1980s, the Rotary became Mazda's identity. The RX-7 arrived in 1978 and spent the next 2 decades building a reputation for handling and engine character that made it genuinely beloved. By the time the turbocharged third-generation RX-7 reached its peak in the early 1990s, producing 255 horsepower from the twin-turbo 13B REW in Japanese domestic specification, the Rotary wasn't a novelty anymore. It was a legitimate performance engine with a devoted following, but the world was changing around it. Emissions regulations were tightening in ways that the turbocharged Rotary couldn't easily meet. In North America, the cost of certifying the third-generation RX-7 for emissions compliance had become commercially unworkable. Mazda pulled it from that market after 1995. The engine that had defined the brand for nearly 30 years was retreating. The company faced a choice that was less about business strategy and more about identity. Abandoning the rotary engine entirely was financially rational. The engineering resources required to keep developing it, the certification costs, the specialist manufacturing knowledge, all of it could have been redirected toward conventional piston engines that were cheaper to build and easier to certify. Other manufacturers had made exactly that calculation and moved on. Mazda didn't. The decision to build the RX-8 wasn't purely commercial. It was something closer to institutional loyalty, a refusal to let the technology that had made the company distinctive disappear because the problems it presented were difficult. The rotary engine had given Mazda something most manufacturers never find, a genuine reason for existing that went beyond building competent transportation. Letting it go would have meant becoming a different company entirely. So, instead, Mazda's engineers went back to work, not to refine the turbocharged engine that had just been pulled from North America, but to redesign the rotary from the ground up, to solve the emissions problem properly, to build something that could survive in the regulatory environment that was coming. That decision produced one of the most ambitious engine redesigns of the early 2000s, and it produced an engine that would win the industry's highest recognition the same year the car it powered went on sale. The engine Mazda built to replace the turbocharged 13B-REW wasn't a refinement. It was a fundamental rethinking of what a rotary engine could be. The Renesis, designated 13B-MSP, shared its basic architecture with the engines that had come before it. 2 rotors, the same 13B family geometry that Mazda had been developing since the 1960s. But the internal engineering told a different story. The most significant change was in the exhaust port configuration. Where the previous 13B-REW used side exhaust ports, the Renesis moved to peripheral exhaust ports, repositioning where combustion gases exited the rotor housing. That single change improved exhaust gas scavenging substantially and reduced hydrocarbon emissions in ways that the older configuration couldn't achieve without turbocharging's additional combustion efficiency. Turbocharging itself was deliberately removed from the equation. The RX-7's twin-turbo setup had delivered remarkable peak power, but it had also been a significant part of the emissions certification problem. Forced induction complicates emission management in ways that natural aspiration doesn't. Mazda's engineers made the deliberate choice to trade peak power for compliance, reliability, and the kind of broad usability that a naturally aspirated engine provides. It wasn't a compromise forced on them. It was a design decision made with clear intent. The result was 2 power outputs depending on specification. The high-power version, available with the 6-speed manual transmission, produced 232 horsepower at 8,500 revolutions per minute. The standard specification produced 197 horsepower. The difference between them came down to intake port timing. The high-power Renesis used larger peripheral intake ports that opened earlier in the rotor's cycle, improving volumetric efficiency at high RPM at the cost of low-end torque. It was an engine that rewarded drivers who were willing to use the rev range, and it made no apologies for that. In 2003, before the RX-8 had even reached showrooms in North America, the Renesis won the International Engine of the Year award. The recognition came from automotive journalists who understood what Mazda had achieved, an emissions-compliant Wankel Rotary, producing genuine sports car power from a package that no piston engine of equivalent output could match in size or mechanical character. The award wasn't sentiment. It was acknowledgement that the engineering was real. The chassis built around that engine was equally deliberate. The Renesis sits entirely behind the front axle centerline, a front midship position that a piston engine of comparable power could never achieve because no comparable piston engine is compact enough. The twin-rotor Renesis package measures roughly 16 inches long and 24 inches wide. That small footprint, placed entirely behind the front axle, produces a near 50-50 front-to-rear weight distribution without adding ballast. No lead weights bolted to the firewall. No repositioned fuel tank to compensate for a nose-heavy engine. The balance came from the layout itself. That packaging advantage had a cascading effect on the steering. With the engine sitting so far back in the bay, the steering rack had to move ahead of the engine rather than behind it, an unconventional position that placed the rack at the front of the engine bay. The steering column routes alongside the engine rather than through the firewall at a conventional angle. It's an arrangement that would have been impossible with a larger engine in the same position. The compactness of the Rotary made it work, and the result contributed directly to the steering directness that reviewers consistently noted when the car launched. On paper, and in the hands of the engineers who built it, the Renesis represented everything Mazda had promised when it decided to keep the Rotary alive. It was emissions compliant. It was award-winning. It was packaged in a chassis with handling geometry that reflected genuine dynamic ambition. But the Renesis carried inherited problems that no award could paper over, and those problems were already waiting. Here's the thing about the Renesis. The problems that eventually defined its reputation weren't surprises. They weren't manufacturing defects that slipped through quality control. They were known characteristics of the Wankel design, documented in Mazda's own service materials, and in many cases, they were the direct consequence of engineering decisions made deliberately. The most fundamental of these was oil consumption. The Renesis injects engine oil directly into the intake ports at a metered rate, a continuous lubrication system for the apex seals and the rotor housing contact surfaces. Without that oil supply, the apex seals would fail rapidly. The consumption this creates, roughly 1 quart every 3,000 to 5,000 miles, is not a symptom of wear. It is the designed operating condition. Mazda's owner's manual documented it explicitly and instructed owners to check and top up the oil at every fuel fill. Most owners didn't do that. Most owners had never owned an engine that required anything other than an oil change every few months. and the idea that a modern sports car needed oil added between services felt like a warning sign rather than a routine task. So they waited. They watched for the oil warning light, and by the time that light came on, the Apex Seal lubrication system had already been running below its design level for some time. The seal wear that followed confirmed what those owners already suspected. The engine was unreliable. What they didn't know was that they had caused it. The Apex seals themselves deserve a moment. 3 per rotor, spring-loaded against the housing, maintaining gas-tight contact through the entire orbital cycle. They are the Renesis's most critical wear item and the source of its most consequential failure mode. When they wear or lose spring tension, combustion gas bypasses them. Compression drops. The engine develops a characteristic cold start difficulty that progresses gradually, over months and sometimes years, toward an inability to start at all. It's a slow failure with plenty of warning, but only if you know what you're looking for. Cold engine operation created a separate problem. At low RPM and low temperature, the combustion process doesn't run hot enough to burn all the oil being injected for seal lubrication. Unburned oil and carbon accumulate in the intake ports, in the spark plug recesses, and around the exhaust port area. Over time, that buildup reduces intake flow and fouls the plugs. Short trips, cold climates, and gentle driving were the conditions most likely to accelerate it. Mazda's own service documentation recommended periodic hard driving above 5,000 revolutions per minute as a maintenance procedure, specifically to burn those deposits off. The car was literally maintained by being driven the way a sports car is supposed to be driven. Owners who treated it gently, who used it for commuting and short errands, were the ones who ended up with fouled plugs and hard starts. The spark plug situation added another layer of complexity that caught even experienced mechanics off guard. The Renesis uses 2 spark plugs per rotor, a leading plug and a trailing plug, positioned at different points in the rotor's orbital path. The trailing plug fires into a partially burned mixture at higher temperature and pressure, so it runs hotter and accumulates deposits faster. Mazda specified different heat ranges for each position, and different replacement intervals to match their different wear rates. Shops that ordered a single plug specification for all 4 positions, which is the natural assumption when servicing an unfamiliar engine, installed the wrong trailing plugs. The misfires and carbon fouling that followed were then attributed to the engine's general unreliability, rather than to the installation error that caused them. NHTSA complaint data for the 2004 through 2011 RX-8 concentrated overwhelmingly in the engine and fuel system categories: hard-warm restarts, stalling, reduced power. The pattern was consistent across thousands of complaints, and it matched precisely the Apex seal wear and carbon buildup mechanisms that Mazda's own engineering documentation described. These weren't random failures distributed across different systems. They were the same failure, repeating, in cars operated the same way, by owners who didn't know the engine they were dealing with. And there was one more trap waiting for any mechanic who tried to diagnose the problem with standard tools. A compression test on a Wankel engine doesn't work the way it does on a piston engine. A healthy Renesis produces roughly 80 to 100 psi under cranking. A healthy piston engine produces 150 to 180 psi. Mechanics who didn't know that looked at the gauge, saw a number far below what they expected, and told the owner the engine was worn out. Good engines were condemned every day by a diagnostic tool that was never designed for the engine it was being used on. That gap between the Renesis and the knowledge required to own one was baked into the car's commercial situation from the beginning. When the RX-8 launched in North America for the 2004 model year, the base price sat at approximately $25,000. The Nissan 350Z started higher. The Honda S2000 started higher. The BMW 330y started considerably higher. For that price, the RX-8 offered 4 seats, a near 50-50 weight balance, and an engine unlike anything else on the market. The value proposition was genuine, and initial sales reflected it. Buyers responded to what the car was on paper and what it felt like on a test drive. The problem revealed itself over time, and it revealed itself unevenly. In cities with established Rotary specialist shops, owners who sought out mechanics with RX-7 experience found people who understood the oil consumption, the plug specifications, the warm-up requirements, those cars tended to survive. In areas without that specialist network, owners went to general mechanics who had never seen a Wankel engine, who applied piston engine logic to a machine that didn't follow piston engine rules, and who produced the failures that the NHTSA complaint database eventually documented in volume. Mazda recognized the pattern early. Technical service bulletins, issued in 2004 and 2005, addressed the hard-warm restart condition directly, providing dealer guidance on diagnosis and revised service procedures. The bulletins acknowledged that the condition was widespread enough to require systematic guidance rather than case-by-case troubleshooting. But the language was careful. Mazda's position was that the hard-warm restart was a characteristic of the engine's thermodynamic behavior, not a manufacturing defect. No recall followed. Owners who experienced it as a reliability failure and engineers who classified it as an operating characteristic were describing the same event from positions that couldn't quite meet. The 2009 model year brought the most significant revision of the production run. The standard power output rose from 197 horsepower to 212. The 4-speed automatic, which reviewers had criticized from launch for its inadequate ratio, spread across the Renesis's narrow power band, was replaced by a 6-speed unit. The metered oil injection calibration was revised. The engine management's idle speed and warm-up strategy were updated to reduce the conditions that produced carbon buildup and hot restart difficulty. Post-2009 examples showed measurably reduced rates of the warm restart complaints that had defined the earlier cars. The revision worked as far as it went, but it didn't change the fundamental thermodynamic behavior that caused the condition in the first place. The Renesis still required oil checks at every fill. It still needed periodic high RPM operation to stay clean. It still used 2 different plug specifications that had to be ordered and installed correctly. The 2009 update made the car more forgiving. It didn't make the car easy. And by the time those revised cars reached showrooms, the forces that would end the RX-8 entirely were already in motion. The yen had been strengthening steadily against the dollar since the mid-2000s, moving from roughly 120 per dollar at the car's launch toward 80 per dollar by 2011. Every Japan-assembled vehicle sold in North America became more expensive to produce relative to its selling price as that movement continued. A car that was already marginal on fuel economy and increasingly pressured on emissions was also becoming harder to justify on a balance sheet. The engineering problem had been partially solved. The commercial problem had not. The Renesis had been engineered specifically to meet emission standards that the turbocharged RX-7 couldn't. That was the whole point. The peripheral exhaust port configuration, the move away from turbocharging, the revised rotor geometry, all of it had been designed around the regulatory environment of the early 2000s. And it had worked. CARB certification for California sales had been achieved. The International Engine of the Year award had been won. The engineering case had been made, but emission standards don't stand still. Euro 5 came into effect for new vehicle type approvals in 2009 and for all new registrations by 2011. The standards tightened hydrocarbon and nitrogen oxide limits in ways that pushed the boundaries of what conventionally engineered piston engines could achieve, let alone a Wankel Rotary whose combustion chamber geometry made clean burning fundamentally more difficult. The Renesis could not meet Euro 5 economically, not with a revision, not with a recalibration. The gap between what the engine produced and what the standard required was wide enough that closing it would have cost more than the car could ever return. Mazda withdrew the RX-8 from European sale in 2010, a full 2 years before global discontinuation. The engine that had won the International Engine of the Year award in 2003 for its emissions engineering was the first casualty of the standards that followed. There is a particular kind of irony in that. The award had recognized how far the design had come from the turbocharged engine it replaced. The Euro 5 failure documented how far it still had to go. Both things were true at the same time. In North America, the pressure came from a different direction. The Renesis returned roughly 18 miles per gallon, combined in the manual specification. That figure placed it among the least fuel-efficient sports cars sold in the market. And the corporate average fuel economy standards that were tightening through the late 2000s made every low-efficiency vehicle in a manufacturer's lineup more expensive to carry. Each RX-8 sold pulled Mazda's fleet average in the wrong direction, at exactly the moment when the regulatory cost of that pull was increasing. The yen appreciation compounded everything. A car already under emissions, pressure, and fuel economy. Pressure was simultaneously becoming more expensive to build, relative to what North American buyers would pay for it. The financial case for continuing the RX-8 was eroding from multiple directions at once, and no single fix addressed more than one of them. No successor was funded. The engineering argument for a next-generation rotary sports car couldn't be assembled in a way that survived contact with the numbers. A new rotary engine capable of meeting the emissions standards coming in the early 2010s would have required development investment that the RX-8 sales volumes couldn't justify. The platform would need to be new. The engine would need to be substantially redesigned again, and the resulting car would need to sell at a price and volume that the previous generation had never approached. Mazda confirmed discontinuation in 2011. Final production ran through late 2011 at Ujina Plant No. 1, the same facility in Hiroshima where every RX-8 had been built since the beginning. The last cars came off the line without ceremony. There was no limited final edition for global markets, no commemorative send-off that matched the scale of what was ending. Just the last of the production run, and then the line stopped. The rotary engine had survived every challenge Mazda had thrown at it for over 40 years. It hadn't survived the regulatory environment of the 2010s. And what came next for the technology told its own story about what survival actually meant. The rotary engine didn't disappear when the RX-8 production line stopped, but what it became says something worth sitting with. In 2015, Mazda showed the RX Vision concept at the Tokyo Motor Show. A long-nosed, rear-wheel drive sports car with rotary power suggested somewhere underneath it. The automotive press responded warmly. Enthusiasts read it as a signal that the sports car wasn't gone forever, just waiting for the right moment. Mazda said little that was definitive. The concept remained a concept. Then, in 2023, the rotary returned in a form nobody from the RX-7 era would have predicted. The MX-30REV plug-in hybrid uses a single-rotor Sky Active AR rotary engine, mounted not to drive the wheels, but to generate electricity for the electric motors that provide all propulsion. The rotary in the MX-30 is a range extender. It runs at a constant speed and temperature, producing current, keeping the battery charged on longer journeys. It never connects mechanically to the road. That constant speed operation did something that decades of engineering revision had never quite managed. It solved the carbon buildup problem. Carbon accumulates in the Renesis under variable load and variable temperature conditions. Short trips, traffic, cold starts followed by gentle warm-up drives. The conditions of ordinary ownership. A generator doesn't experience those conditions. It runs at one steady state, chosen for efficiency and emissions compliance, and it holds that state until it's no longer needed. The thermodynamic environment that caused the RX-8's most persistent ownership problem simply doesn't exist in the MX-30's application. The rotary engine that struggled with carbon deposits under the demands of driving a sports car through daily traffic turns out to be well suited to the narrow operating window of a generator running at a fixed point. There is something quietly telling about that. The Wankel rotary's strengths, its compactness, its smoothness at steady RPM, its mechanical simplicity relative to a piston engine, are genuinely well matched to generator duty. Its weaknesses, the carbon sensitivity, the emissions difficulty across a wide load range, the fuel consumption penalty, are minimized when the engine never has to vary its output. The application that finally gave the rotary a stable future is the one that removed almost everything that made owning a rotary sports car complicated. Mazda has now produced rotary engines without interruption since 1967. That continuity is real, and it matters to the people inside the company who have spent careers on the technology. But the last rotary to drive a car directly through its own mechanical output was the Renesis in 2011. What survived was the engine. What didn't survive was the thing the engine was built to be. The RX-8 community that remains understands this clearly. Specialist mechanics who learned their trade on RX-7s still operate in enough cities to keep the cars alive. Engine rebuilds, replacing apex seals and rotor housings and associated components, run between $3,000 and $6,000 depending on the extent of work. The SE 3P chassis, where kept clean of corrosion, outlasts multiple engine rebuilds. Owners who manage the oil, drive the car the way the service manual asks, and find a mechanic who knows what a Wankel compression reading is supposed to look like. Keep these cars running well past 100,000 miles. The knowledge exists. It just requires effort to find and commitment to apply. What the RX-8 demonstrates in the end is that solving the specific technical problems of a technology doesn't guarantee that technology's survival when the world moves faster than the engineering can follow. The Renesis was a genuine solution to the problems that killed the turbocharged RX-7. It was just not a complete enough solution for the standards that arrived next. The Rotary engine wasn't lost. It survived. It's sitting in a plug-in hybrid right now, spinning at a fixed RPM, generating electricity for motors that do the actual driving. That continuity is real, but there is a difference between a technology surviving and a technology thriving in the form it was built for. The Renesis was engineered to prove that a high-revving, mechanically distinctive engine could exist inside modern regulations, inside a practical four-seat car, inside a market that valued character alongside efficiency. The engineering was genuine, the intention was sincere, and the world it was built for simply didn't hold still long enough for any of that to matter. The Rotary engine gave Mazda something most manufacturers never find, a reason for existing that went beyond building sensible transportation. The Renesis was the best version of that idea they ever produced. What it was meant to become and what it actually became are two different things. And that distance between the two is something the numbers in a balance sheet have never quite been able to account for. If this kind of story stays with you, there is another one worth watching. In 1998, Toyota faced an impossible choice between the past and the future, and the Land Cruiser 100 was the answer. That video is up next.